when we last met, last Thursday, it's been a while, we were talking about the law of the sines. Based upon the law of the sines, which was on a pink note sheet that we had for you, we did some law of sines discovery on the front side, and then you did like 3 examples on the back side. It was wonderful. You figured out that the sine of angle A divided by side A is equal to the sine of angle B divided by side B is equal to the sine of angle C divided by side C. Okay? And we found that the sine value of an angle is proportional to its side length within any triangle, and that includes non-right triangles. And we were all kinds of excited because we could solve non-right triangles finally. Woohoo! Yahoo for school. Okay? So, what I would like you to do now is I would like you to remember the law of the sines and solve this particular triangle. Let's see, so this angle up here is going to be 65 degrees. Okay, so then we've got the sine of 70 degrees all over 15 equals the sine of 45 degrees all over side C. And we've got the sine of 70 degrees all over 15 equaling the sine of 65 degrees all over side A. What do we got here? So side C is 15 sines of 45 divided by the sine of 70. So I get side C is 11.287. Much the same, except instead of a 45 degree angle, now it's a 65 degree angle. And so A, side A, is 14.467. Yes? Yes. Love it. Just when you think you have all the answers, I'm going to go and I'm going to change the slide. Okay? Today we're going to talk about the ambiguous case of the law of sines. Okay? Law of sines is great, limited in its scope, okay, but still great. But it's also got a little more, sassy side to it. Okay? So we'll always be given 3 bits of information. Okay? Either we're going to be given 2 sides and an angle, 2 angles and a side, 3 sides, okay? All that different ways to do things. Okay? So if we're given the 3 sides of a triangle and we're tasked with solving that triangle, we're going to use law of cosines. Okay? We're going to get to the law of cosines tomorrow to refresh it for you from geometry. Okay? Or if we're given the side or two sides and the included angle. Again, both of those we're going to use the law of cosines. And that's going to be tomorrow. Okay? If we're given two angles and their included side, what do we use? What? Give you another chance. What? Law of sines. Yeah. Why? Why can we use law of sines?
Because we can find the other angle.
You can find that third angle, and then we've got that one complete fraction. Right? Okay? Love it. What about if we had angle side? Still there's law of sines, right? That's actually the one we just did. We just did an angle side one. Okay? That's that case. We just did it. We use law of sines. Not a problem. Bam, we can do it. Love it. Going down. Going down. You'll get to why I say normal in a minute. Yes, ma'am.
So the order of the angles and the sides doesn't really matter.
In those two? No. Okay. Because we got the two angles, so we can find that third angle, which then that gets us the complete, or the one complete fraction for law of sines. Okay. What about angle? Given the three angles of a triangle. Can we solve that triangle? Because we could say that this angle, here let me color code these angles. So this angle, these two angles, those are equal. But they're on two different sized triangles. And these two angles would be equal. They're on two different sized triangles. And then these two angles would end up being equal. But they're on two different sized triangles, but all the angles are the same. So we can't solve the triangle given just the three angles. So we have to be given at least one side. Okay? So, it's the angle side case, or the side angle, depending upon how you like to write it out. Okay? Some people like ass. Some people don't. Okay? Alright? Okay. Alright? That's the case that we're going to talk about today. So, it's the angle here, that side, and then that side. Okay? This is where things will get a little confusing. Okay? Alright? So, what I would like you to do is, I want you just to try and solve that triangle for angle B. I just want angle B, I don't want angle C inside C. So we're just solving for angle B. Go for it. So that be? That'd be inverse sine of 31 sines of 20.5 degrees divided by 12. And what do we got? What did you guys get?
64.7.
Is that what you got, Alex? Okay. Really? 64.8?
0.7.
0.783?
Yeah.
Uh-oh. So, wait, so you guys got 64.783 degrees? Check this fraction just to make sure that I didn't miss something. Something's not starting to cool it here. Sine of 20.5 degrees divided by 12. Put that on your calculator or write it down. And then sine of 115.217 degrees divided by 31. Put that on your calculator. See what you get. What are we coming up with? What? They're close? Not quite exact? Well, we kind of rounded, right? But, uh-oh, who's right? What? Both? Yeah, both are right. This is the ambiguous case. Okay? We're both right. Okay? So let's talk about the ambiguous case. Okay? So ambiguous, the word ambiguous, means that it's open to more than one interpretation. That's a long word. Okay. So, what I'm going to give you now is I'm going to give you now 6 different scenarios. Okay? So there's 6 different scenarios that we have. First scenario is if the given angle is obtuse. Now I'm going to be smart this time. Whoa! Maybe not that smart. Smartness. Okay? Alright, so my given angle here is obtuse. So I'm given this angle right down there. Now, the 2 sides that I would have then would be A and B. Okay, because that makes my angle side case. This only happens, the ambiguous case only happens in the angle side scenario. Okay? So I'm given that. My first option is that my opposite side, let me push this up a little bit, push it, there we go. My first scenario is that my opposite side is greater than my adjacent side. So that would be B is greater than A. If that's the case, we only get one triangle. We get one triangle, we use the law of sines like we've been using the law of sines since last Thursday. Bada bing, bada boom, we're done. Move on with your life. Okay? If I flip that around and I say that the opposite side B is shorter now than my adjacent side, ends up looking the same. Of course it does. So if my opposite side now is shorter, it actually is going to look like that. How many triangles do I get? None. So we get no triangle, and we can't solve. You're done. Okay. Questions on either one of those two?
How come, so does the hypotenuse or how does that
We don't have a hypotenuse in this case
Oh,
because
yeah.
we don't have a right triangle. Yep. Yep. Okay. Now, my given angle is going to be acute. Opposite longer than adjacent. You gotta go way out more. So there's my situation. Now I have an acute angle. My opposite is longer than my adjacent. We're great, we're grand, we're golden because there is one triangle and we can use the law of sines to solve it. It's this next one. Let me bring this one up. Come on now. There we go. It's this one where here's my given angle. Here's my adjacent side. There's my opposite side. Okay? So when B is shorter than A, that's when we get all crazy. Okay? So we're going to call this the height because it's the height of my triangle. Okay? It's the perpendicular distance down to the other side. So if B is equal to H, what do we get? What? We get one right triangle, right? Okay, because this side then would come into here. So shabam, we would get one right triangle. And then we can use SOHCAHTOA to solve it. If my height is bigger than my opposite side, remember my opposite side in this case is B. If my height is bigger than my opposite side, how many triangles do I get? We get right? None. Because I can swing this through here and it never touches that side. Okay? So I get no triangles formed here and I can't solve. Now, if B is longer than H, I swing it through and it's going to touch there. I swing it through and it's also going to touch right there. Probably the worst seat you could pick.
That's alright.
Okay.
I'll make it work.
Well, here, there's one. Well, just come to that one right there. Then you can actually see. You don't have to turn around.
Alright.
You know what I mean?
Yeah.
Okay. So if that's the case, where the opposite side is longer than H, you get 2 get rid of that one. Oh no. There and there. You get 2 triangles that get formed. Okay? And that's the ambiguous case. Oops, I gotta move B. Because you get 2 triangles, that means that you've got to find 6 different values. Because on one triangle you have to find 3, and now that you got 2 triangles, now you got to find 6. Okay? So, let me wrap this up here at the end. I'm going to break this up into 2 videos, so let me wrap this up now. So, if the opposite side is bigger than the adjacent side and we're in an angle side case, we only get 1 triangle formed. And we use the law of sines to solve it. It'll always be 1 triangle. We'll always use the law of sines. Bada bing, bada boom. Okay? If the opposite side is smaller than the adjacent side, then we could have 0 triangles, 1 triangle, or 2 triangles. So we've got to do some more checking. Okay? The first check that you're going to want to do is, what is your angle? If your angle is obtuse, then it's no triangle. And if your angle is acute, you got to check your H.